Right now on Amplified, we're about to find out how engineering meets art in structural design.
To make the problem even more complex, the world is urbanising at a huge rate. And the amount of building compared to a city the size of New York will have to be built every month until around 2060. So it's an enormous challenge.
Hi there, my name is Dusty Rhodes and you're welcome to Amplify, the Engineers Journal podcast. As we know, engineers are naturally creative, from problem solving to designing and planning. But when you combine that with visual creativity, it leads to unique and beautiful things. Today we're chatting with an Irish engineer who's using his engineering skills and artistic flair to design some of the most impressive structures across the world. We'll find out how he blends his love for engineering and art with a passion for responding to the climate crisis and what he's learned from working in 20 countries across the globe. I'm delighted to welcome the founder of VOLUTA, Eoin Casserly. Eoin, how are you?
Great, thanks Dusty. Thanks for having me.
So listen, tell me, what got you into this wonderful, crazy business we call engineering?
Well, I suppose I didn't really have a very clear idea of what I wanted to do, but engineering seemed to have this combination of technical skills. I suppose I saw a lot of my strengths in maths and physics and these very technical subjects, but also other areas, languages, art, design. And I think the handy thing is that you get to combine all of these with engineering. So I studied structural engineering with architecture in UCD, but probably it wasn't until I moved into my first job in Paris that I really started to think of it as something I wanted to do. I was working for a company called Tess in Paris, and it was a bit more glamorous than what I would have expected for an engineering job. So the company at the time was designing the Fondation Louis Vuitton, this enormous museum on the west of Paris. And because of this, it was a new company. It was only about a year established, and they were working in a Louis Vuitton office. So I was a 22-year-old guy from Sligo going to work every day in a Louis Vuitton office with these incredibly cultured, multilingual people who also just happened to be as well really competent and brilliant at their jobs. So it really opened my eyes to what was out there, and I think drove my career then.
And they say one of the things about engineering is that once you have that, it's a passport to the world. And you've opened up by saying you worked at Louis Vuitton in Paris. What a great start! You've worked elsewhere in the world. Give us a sample.
So I, after I finished my master's, I moved to New York, and eventually started working for a company called Flair, which is a German company with offices in a few countries around the world. From there, I was mostly working on US projects, a lot on a new development at the time called Hudson Yards, which was a $25 billion real estate development, basically making a new neighborhood within New York. And from there, worked a little bit on stuff outside the US because I had the experience in Paris. I advised on some projects there as well. My visa ended in the States, and then I decided to move to the headquarters of that company, Schleswig-Holstein, in Stuttgart in Germany. At that stage, I was working as, I suppose, the technical lead for glass projects. So anything with a bit of glass in it, I was giving technical input, and they're one of the leading companies in the world for architecture with glass. So I was advising on projects for, say, the Chinese office, the Paris office, doing a few projects in Brazil, the US, a few in Canada, so all over the world really. And then from there, I ended up leaving that company during COVID to set up my own company. Initially, I was living at the time in Palermo, or nearby Palermo in Sicily, where my wife's family are from. And from there, I had the idea to eventually move back to Ireland and set up my own company, work on projects across the world. So from there, from my company here in Sligo, I've worked on projects in Oman, the Netherlands, a few in the US, Belgium, Austria, Germany, and hopefully some soon to come in Ireland.
You said that you met your wife in Italy. The name of your company, VOLUTA, strikes me as being an Italian word. Is it? And what does it mean?
Yeah, well, I actually met my wife in New York, but her family's from Sicily, so we ended up moving there during COVID. So it's the name of a seashell. It was actually probably the toughest thing about starting a company was finding a good name. So VOLUTA is the name of a seashell, and it's also the name of a type of facade detail. So those two things, I think, combined give it a sense of what the company does. So we're really guided by the beauty and efficiency of nature, because if you imagine a seashell, say a snail or whatever, doesn't want to spend undue energy making this what they have to live in. They want to do in the most beautiful, I suppose, efficient and least energy intensive form they can make, which ends up being really beautiful. And so taking inspiration as well from what's gone before me is a big part of the company.
And do you feel like kind of that little creature? Because you're just one. No, but what I mean, seriously, you're one human being and you're designing these huge, big projects, which are, 1,000 times bigger than you are. And you're keeping in mind the functionality of it, but also how it looks and the practicality of it. Have you ever had a design dream in your head that was like structurally or logistically too big?
Just on the first part, I don't think I can ever say, and I don't think anyone can really ever say that they're the sole.
No, of course, no. I don't. I'm not putting it all down to you. Don't worry. You're involved in it. I know. Yes.
Yeah, it's something that I thought before I started working in all of this, that it was, and it's something that's portrayed a lot. There's one, it's creative genius alone in engineering, which is never the case at all. That it's always a team of people. There's always a huge amount of compromise. That really a lot of the time you're just a facilitator that for other people's visions or for a combined vision. But there's limiting factors in terms of, the reality of materials and what can be achieved with them. But I think, there's a great quote that architecture is dancing in chains. So that you have these limitations, these chains, but that you can still dance when you're held down by them. But I think, there are limitations, but you can always work around these. There's limitations can create a box for something new, and that's part of the beauty of it all, I think.
Do you think that when you have limitations, when you're trying to achieve something, to design something, that because of those very limitations, you come up with something brilliant?
Exactly. I think that's the beauty of it all. That if you're designing without these limitations, then you're purely, you might as well be a video game designer. It's not based in reality. We have all of these realities or these limitations in what's actually constructible, that you really have to be, you can't be sitting in an ivory tower just saying, get this done, I believe this is possible, without basically doing it yourself. You have to first understand how someone can build it. I think that's a huge part of it all, which unfortunately a lot of engineers, I think, are a little bit divorced from the construction side of things, and architects too. That you really have to understand that side of what can be built, to understand the sequence of what can be built, even financial limitations of who you're working with. That I think all of these combined, these limitations are actually what create the best projects.
Do you have any particular project where you kind of started off going, oh my God, this is never going to happen, and then you turned it around or something?
There were a few projects where we were doing things that had never been done before. So, we're world first. And there's always an idea that if you're going, say, higher or using something that hasn't been used before, that from first principles, you can figure this thing out. But there's always a shaky moment where you will question yourself and wonder, how do we test this? How do we ensure that everything is safe? But that's the process, I suppose, that you have to believe it.
One of the projects that I've seen that you were involved in, I think, is one that everybody listening to the podcast will know. And that is back in your time in New York City. And I don't know if it's part of the project where you're literally developing the new neighborhood over the railway. But the Edge in New York is a huge tourist attraction where literally, I don't know what floor it is, but it looks like the 257th floor is you walk onto this massive balcony thing and it looks like you're hanging over the edge of the building. What was your involvement in that project?
So I was the project manager and lead engineer for the work on the secondary structure and facades, glass floor, the glass perimeter, basically everything apart from the primary structure, what directly attaches to the building. Sorry, I also didn't. There's a staircase in it leading up to a second store that I also didn't have any involvement in, but basically everything else I had my hand in. I actually haven't been to it since it's been finished. So I suppose it was one of the really unique parts of that was that it's in if you think about when I was going back to think about how this can be constructed. So there was only basically, I think it was one night allowed for closing off of the roads in New York to transport this thing. So there had to be a huge amount of pre-assembly. So there were modules, what are called modules, basically individual pieces connected together, done in a factory, which would then be assembled almost, if you can imagine it, almost like Lego on site. So craned up around 400 meters high and then fit to within 3 millimeters of tolerance of each other. So the 3 millimeters of tolerance of each other needed to be exact because of actually cleaning it. So allowing the facade maintenance teams to come down the rails. And if those rails were even slightly misconnected to each other, by 3 millimeters or more, then they might get stuck. So this involved a huge amount of analysis on the individual modules to ensure that there was enough adjustability to connect them in the air at 400 meters with no scaffolding underneath, which is another big part of it. So then there was also, apart from the modules, which is the structural part and the facade part, there's also the glass. So there's a 3 meter tall cantilevered glass barrier around the edge and the highest outdoor glass floor in the world. So for these were, I suppose, a little bit different to the more heavy structural steel parts of the modules. They were more fine, lightweight architectural designs. And we really had to find a balance between transparency and the structural stability of the glass, because this is where, you might look at glass in your window, but it's not holding up anything. The glass in these is holding itself up and also, holding up a full group of people standing on it, jumping on it, whatever, and needs to maintain its capacity for many, many years. So you could go very thick with the glass, so have many, many layers, but you lose a bit of the transparency. You lose the whole idea of what you're putting it there for the first place. So finding a balance there with some fairly complex finite element analysis and through testing as well to figure out exactly the minimum that we can use that will still be safe and still be structurally sound.
That sounds amazing. I mean, it's such an iconic thing, being the Edge in New York. Was that your biggest challenge to date, or have you dealt with something even bigger?
Yeah, lots of big projects like that. One that comes to mind is our first project with VOLUTA, we're finished with it now, Oman Botanic Garden. So this is the biggest project in the history of of Oman, making the biggest botanic garden in the world. I was the technical consultant for the grid shells in this. So the idea behind this botanic garden is to showcase the diversity of plants in Oman, which actually has lots of different climates. And so there's, in the north of the country, in the mountains, there's a northern climate, like juniper trees, things like this. And then in the south, they have what's called the Kharif season, which is monsoon season that actually brings a lot of green, very unexpectedly, in the south of Oman. And this huge biodiversity, they wanted to showcase this, partially for tourism and also just to show what amazing biodiversity Oman has. So in these two grid shells, these two quite free-form looking steel and glass structures, the idea is to house in the northern biome the plants of the northern regions, and in the southern biome the plants of the southern region. So this was, and still is, just an amazing project. The scale is outstanding. The architect sent me on photos from site a few weeks ago, which really, these things look big on a computer, but once they're actually built, it's another level entirely.
A lot of the projects that you're talking about are in public spaces and they're for the public. Is the experience of the people who's going to experience these spaces important to you while you're doing the design?
Oh, hugely. I mean, to everyone in the design process, I think that's the goal. I mean, there can be lots of little things that you obsess over that maybe people might not notice, but it's always the end goal is the end user.
And with engineering, when you're coming to having to do a design for a particular purpose, and you've got so many challenges to overcome and you've figured them all out, is then also adding the fact that the public must think this is amazing. Does that add to it, or does it make it a more interesting project?
Oh, it definitely makes it more interesting. I mean, it's always really interesting to see how people engage with structures and with the architecture, because it can be completely different sometimes to what you expect or to what everyone in the design team is imagining. And I think that's the beauty, that you can spend years on something, but someone else can just come and have a completely fresh perspective on it after a few minutes.
And as well as thinking about that, a factor that the public have to be wowed by this design, you like working with glass as well. In what ways does that make the structural process more difficult?
Well, for one thing, glass has very different tolerances to the more standard building materials. So you're often looking at tolerances of 1 millimeter for glass, where, for steel, you might be looking at 10. It's a very fine piece of design work that you have to really understand how things will be installed, how they will be maintained, which is critical. Obviously, you don't want, if you design this brilliant piece of glass, that it just gets dirty after a few weeks and then remains dirty forever. But you have to understand the process of how everything's done, the fabrication process, installation process, obviously the first principles of the engineering. And it's quite a new, well, it's maybe not that new, it's maybe, probably 40 years where people are working with structural glass, so glass to actually hold up itself or other parts of a building. So it's quite a niche area, with research sometimes coming out that might change your perspective on it.
What do you mean by that?
Well, because it's not as well studied as other materials, the research on it can be, I suppose, maybe a bit more groundbreaking than, for example, with steel, where a lot of it has already been figured out. So, for example, there isn't, or it's coming out soon, the Eurocode for glass, a design manual for glass, which, of course, with lots of other materials is already present for a long time. So there's debate. It's very different in every country as well. There'll be huge differences in standards of what can be used for glass structures, say from Brazil to the US or to Germany. A big part of that is having to rely on your knowledge of first principles of the chemistry, the manufacturing of the material, to know what will work, what's safe, what isn't. So take little pieces of these codes from all around the world to add to your knowledge.
It's fascinating to hear these things that you're passionate about with the design and the materials and the glass and everything, and how you're able to just bring it into your work. You're also passionate about the architectural response to the climate crisis. Can you tell me a little bit how you weave sustainability into your work?
Yeah, well, I think it's the big challenge for the construction industry in general. So it's something that isn't talked about a huge amount, especially not in, I suppose, mainstream in papers, for example. You don't see that the buildings and construction in general accounts for normally around 40% of the world's global greenhouse gas emissions. You'll always see things about, say, reduce flying, which is a great idea, but no one ever talks about using less concrete in mainstream discussions of the climate crisis. But, in addition to about 40% of global greenhouse gas emissions, around 30% of global waste is produced by the construction industry. It's a massively wasteful industry. And it's a big focus of VOLUTA, this shift to a more sustainable method of building. There's just to make the problem even more complex, the world is urbanizing at a huge rate. And a city the size of New York, basically, if you take the whole world combined, the amount of building compared to a city the size of New York will have to be built every month until around 2060. So it's an enormous challenge. Some people rightly see that a big part of that challenge to face this, or the solution to face this challenge, is a shift to biomaterials, bio-based materials, such as timber, bamboo, stone, because concrete, steel, they're very carbon intensive. And so this is something we're focusing on with VOLUTA, a shift to biomaterials. Also, a big part of what we do is we work with complex geometry structures. So often structures that are curved in two directions. So if you imagine, say, a ball, this is curved in two directions. If you imagine an arch, this is only curved in one. But the two directions don't necessarily have to be the same one. So if you imagine a saddle, one curve is in one way, the other curve is in the opposite way. So this is one of the big kind of untapped potentials of how engineers can approach the climate crisis, is the power of geometry. And a great voice in this regard is Philippe Bloch, Professor Philippe Bloch in ETH in Zurich. He's really pioneered what's called the war against bending. So elements that are in bending, so for example, like beams and slabs, it's quite an inefficient method of construction, or method of internal stress, where if things are in tension, so being pulled apart, or compression, being pushed together, it's much more material efficient. And so a lot of what we design in terms of grid shells, cable nets, these are tension or compression structures which use a lot less material in comparison to these bending structures. So if you look around yourself, you'll only see buildings at right angles. Now, this means that everything is in bending, more or less, or most things are in bending. And this is a really inefficient way to use material. So this is a big part of what we do with VOLUTA, is harnessing the power of geometry and using biomaterials to really minimize this carbon footprint.
Let me change subject for a few minutes, Eoin, because you hold the title of Chartered Engineer of the Year with Engineers Ireland, and congratulations on that. Can I ask you, how does it help you to be a chartered engineer specifically?
Well, it's great because I can work in Ireland. So all projects in Ireland have to have a chartered engineer, and this allows me. I've worked on projects in over 20 countries, but never in Ireland, never where I'm from. So being a chartered engineer allows me to work in Ireland and hopefully bring some of what I've learned abroad and some of the expertise I've gained to Ireland as well.
Well, needless to say, there's more information about going from engineer to chartered engineer on the website at engineersireland.ie. Can I wrap up today, Eoin, by asking you, I mean, you're obviously a hugely experienced person, and with all of that global knowledge that you have, from your experience, what would you like to see change in the world of engineering?
So I suppose, like I'd mentioned, a shift to biomaterials. So cement production alone, just one part of concrete, is 8% of global greenhouse gas emissions every year. We're running out of materials from the way we construct. A crazy thing that happens is that the UAE, which is, I think, 99% desert, actually imports sand from Australia for concrete.
You're kidding me. That somebody is selling sand to the Arabs, literally.
So it's sand from rivers is actually much more useful as aggregate, for use in concrete because of the friction coefficient. But we're going to run out of materials like this, very fast, unless we start using renewable sources and using less. So using bamboo, which is a really fast-growing material, has huge potential, especially in the developing world, because it can be grown in almost every climate. A shift away from the very carbon-intensive materials like concrete and steel. I would hope that there'd be a shift to more circularity in construction. So reusing materials. Most of the time, something is demolished and basically it just becomes waste. Something new is built from virgin materials in its place, which is an incredibly wasteful process. So I would hope there'd be a lot more circularity. And then something that I also lecture in university and ATU, and I don't lecture in engineering, I actually lecture in architecture. And the reason I chose to do this was because I think there needs to be a much greater integration between architecture and structural engineering, for one thing. Because right now, especially in Ireland, it's quite a vertical process where an architect might design something, a structural engineer has to make that work, where I think there's a lot more to be gained from a collaboration and creative tension at the start of a project. It's really where the structural engineer can contribute the most, can make a huge saving, especially in terms of carbon. I think this creative tension creates something much better than the sum of its parts in the end.
And it's like you said earlier, where you have limitations, you have to come up to solutions around that. And actually, often you will end up getting something even better because of those limitations. So
Exactly.
Listen, if you would like to find out more about Eoin Casserly and some of the topics that we spoke about today, you'll find notes and link details in the description area of the podcast. But for now, Eoin Casserly, founder of VOLUTA, thank you very much for joining us.
Thanks very much, Dusty.
If you enjoyed our podcast today, please do share with a friend in the business. Just tell them to search for Engineers Ireland in their podcast player. The podcast is produced by dustpod.io for Engineers Ireland. For advanced episodes, more information on engineering across Ireland or career development opportunities, there are libraries of information on the website at engineersireland.ie to check it out. Until next time, from myself, Dusty Rhodes, thank you for listening.